Problem 31. The radius of a circle is increasing at a constant rate of 0.2 meters per minute. In terms of the circumference C, what is the rate of change of the area A of the circle in square meters per minute? I miss areas measured in square meters, not in meters. I'll fix that in the file online as soon as possible. But let's look at this problem, okay? It is a related rates problem. And let's see what we've got here. So the radius of the circle is increasing at a constant rate of 0.2 meters per minute. So this is the radius. So this means that the change in the radius with respect to time t is equal to 0.2. And so I'm not going to put meters per minute in there. In terms of circumference C, what is the rate of change of the area? So first thing, let's write the area of a circle and see what happens. So the area of a circle is equal to pi r squared. And I need to relate these rates. So this is the area in terms of any radius r, and I can't put in any value yet because the radius is changing and the area is changing, but what I can do is take the implicit derivative of both sides. So the derivative with respect to t of a and the derivative with respect to t of pi r squared. And to take this, pi is a constant, so I can bring that out to the front. And this derivative with respect to t of a is just dA dt. And that will equal pi times the derivative with respect to t of r squared. And to do this derivative correctly, I take the squared out to the front, get r to the first, but I actually have to do chain rule because this r is a function that's changing with respect to t. So to do this correctly, I know that dA dt, I still have that, dA dt will be equal to pi multiplied by, this right here becomes 2r times dr dt. You have to do chain rule on that radius because the radius is a function of time. Okay, and we're almost there. So we're looking for the rate of change of the area. Let me mark this right here. The rate of change of the area, and that is dA dt. And I also have this piece of information right here, so I can put that in for dr dt now that I've taken care of the relating rates. So we know that the change in the area with respect to time will be equal to 2 pi r from this right here. And then I also have times 0.2. And I could multiply this and get 0.4 pi r, but I'm looking at my answer choices here and they look very different. And here's the last piece of this. We are actually looking for it in terms of the circumference C. And remember, the circumference of a circle is equal to pi times the diameter, but that's not the one that we're going to use. We're actually going to use 2 pi r. And if you look right here, I have a 2 pi r in my formula for the rate of change of the area, so I'm going to rewrite this to say that, okay, dA dt, I still have that over here. And since 2 pi r is equal to the circumference, and I want things in terms of the circumference C, I'll replace that with c, the circumference of the circle, multiplied by 0.2. And I get my answer choice here, which is going to be E.